word by introduction, and this is Dialog APL. Before I start the presentation, I would like a show of hands if anybody knows what Dialog APL is or have heard of it or something like that. Okay, that's some people. I am happy that some people know about it. So coming up next is APL that was originally a paper by Ken Iverson that was called a programming language. That's not where APL comes from, but it is also a programming language and APL. So it is a symbolic array-oriented programming language. APL stands for Array-Oriented Programming Language. It is a language that changes the way you think about problems and data with a powerful and concise syntax, and it lets you develop shorter programs so that you don't have to think more about telling the computer what to do, but you have to think more about what you actually have to do instead of spending time communicating with the computer. So it is symbolic array-oriented programming language for computing algorithms to communicating algorithms to computers and humans. So I am not going to go into language internals. I am here to explain what the language is about and how you can use it and how people are using it and what it stands for. So starting with symbolic. So we've all done math in our school days with symbols and symbols and symbols, except for like some word problems in only first grade, but all for advanced math is done with symbols. So it comes from an ideology that if you can do math with symbols, why can you not program with symbols? So all of us understand what these symbols are: addition and multiplication. These are slightly different symbols, but we still understand one is a talking symbol and one is a thought symbol. But so symbols are very easy to communicate. So in APL, how we write code is this is a symbol. So it's a down arrow. You could guess what it stands for, but let's say this is drop. So what drop does is exactly like slice. So you say one drop something in an array. Similarly, you say take. One takes something in an array, takes the certain elements from the mentioned array. There's reverse, there's transpose. There's a lot of symbols, but I'll try to keep it concise. So what array-oriented means is all of the operations are done on an array instead of singular numbers. So all of the language is based on the fact that array is the most used data type in programming. So something like 2 plus 5, 6, 7, 8 would give you 7, 8, 9, 10. It applies the operation on the entire array. Similarly, to drop 5, 6, 7, 8 drops the first two elements, gives you 7 and 8. To take 5, 6, 7, 8 takes the first two elements and does not take the last two. Then something like reverse, you could guess what it does. 8, 7, 6, 5. It reverses the array. So it not only works on a singular array, but it works on n-dimensional matrices. So that's very useful. So something like our table over here, try APL now, would be reversed into that. You could mix two symbols and it reads as 2 drop reverse of table. So you drop two columns, reverse the table, you get WON. And it works as a Cartesian thing as well. 2, 1 drop reverse table gets you ONN. Then you can also transpose it, so it has all the matrix stuff in there. Then, so this language was originally, the idea of languages like this was originally founded by Ken Iverson. Ken Iverson got a Turing Award for his paper, Programming Language, which deals with programming languages, and Dialog is a maintainer of this programming language that was ideated by Ken Iverson, and this is Dyalog APL. So I showed you some symbols. There's a lot of symbols that you can use. All of these do a multitude of tasks, and it's very hard to put it in a 20-minute presentation, but I'll try. So there's a myth with APL that if you're not writing words, how are you describing your code? The myth is that APL is unreadable. So a basic code example would look like this. So You'd say that it is unreadable, but somebody who does not know maths would also say that this is also unreadable. But anybody who has studied high school math would know what this exact statement is, and it's a matter of perception. So there's a lot of people that can speak this language, this is Greek, and I'm not sure how many people here would call this readable as well. There's some languages that read right to left, and there's a lot of people that speak those as well. There's languages that read top to bottom, and that's also readable for the second most populous country in the world. So I'll explain what this code is. So this is what this code looks like in JavaScript, but you'd say that you don't write JavaScript like that. So I'll change it a little bit. You'd say you write JavaScript like this, but you won't write it as a single line command. So change it again. So this looks like a decently readable one, but I'll add some spacing to it as well. So okay, now we can read some JavaScript code. So this is fairly understandable. There's a sum of all of the elements of the array. There's a product of all of the elements of the array with a reduce. There is a function for ranges and a function for factorial and the mega function at the end. I'll show you what this looks like in APL. So you don't really have to write APL as a single line thing. You can write it as multiple functions like a normal programming language. But the thing is, so addition is just addition. You don't need to do anything else to it. Then multiplication actually has the real multiplication symbol, unlike almost all programming languages that use the hacky way for multiplication. And reduce, which has a lot of syntax in JavaScript, converts to just a slash, that is replicate. So it reduces, so it's a addition reduction of the entire array that gives us the sum and the product of the array in the two functions. So then this is one drop, like I told in the previous slide. We have one drop again, that is slice. And then there's a map of factorial. The two dots here is called each, that is the same as x dot map. And but over here we have this whole syntax for calculating the factorial, but since it's based on math and it was made by Ken Iverson because he was frustrated with there's no programming language that understands mathematics like mathematics. So we have a symbol for factorial. Now you'd notice that all of our function names are 3 characters long, and our actual functions are just 2 characters long and 1 character long. And you would understand that that's a sum reduce and a multiplication reduce and a factorial. And at the end, you have to do a divide and a minus in the end as well. So I'll say sum is kind of understandable. PRD could mean anything. Nobody uses PRD in their syntax. So might as well we could just replace all of it here. Reduce the spacing. Now you can read the function that was there in the previous slide. So it is kind of readable actually. So, but okay, readability is there. We'll talk about some actual stuff that people are making with the language. So where is this used? So APL is used in research. This is somebody making understanding metallurgy data with APL. This person also does data science with APL in metallurgy. This is a project by somebody who was simulating wind and air currents using APL. Then this is a project that maps 3D data and particle information in APL. Then APL in academia, APL is used to do statistics and teach statistics in high school and colleges. Then this is somebody making a quantum computer using APL. This is a lab in the US that is doing that. Then people also teach preschool, not preschool, but school mathematics with APL because it's very easy to grasp by anybody because it's very similar to mathematics. Then it's not just teaching and research, people use it in the industry as well. So here is Big, who's a jewelry retailer, using Dyalog APL for a cloud-based system. Then this is Cosmos, which is a healthcare software for managing all of the healthcare data. Then this is somebody using APL with modern features like Docker and all of the cloud infrastructure and more. People do a lot of hobby stuff. So this is Ray Cannon doing a piano simulator with APL. It plays the keys, and this is somebody making factoral drawings with APL. This is somebody making FM radio and trying to decode and encode the signals of FM radio with APL. So there's a lot of application, and there's a lot of people in the world using APL. So APL comes with a dialogue interpreter. So it's available on 6 platforms. Anything you can basically imagine. There's Windows, there's Docker, there's Linux, there's Mac ARM, Mac Intel, there's Raspberry Pi, there's a Jupyter kernel, there is all sorts of things. Then it also comes with a compiler. The compiler is still under development, and this is called CodeDefense, and this is open sourced and is still under development. The interpreter is fully functional for use for commercial purposes and for research purposes. So I would say everyone should at least once try APL. Tryapl.org is our online tool to try APL. I would love if you all could try and let me know what you think about it. So, Dialog APL, it has its own IDE for Windows. There's a different IDE called Ride for Linux and Mac. There is a package manager that has a decent number of packages. I won't say it's big, but it has a decent number of packages. Then we have a project manager called Cider. Then it's available on 6 platforms. It has object-oriented programming, it has functional programming, it has UI tools, it is interoperable with Python and .NET. And one thing about APL that really struck me was you don't need to learn English to write code in this language. And every other programming language uses English to convey to the computer about what you're doing. But because this is like math, you can do it with any language with just using symbols. And you can understand what it's doing even if you don't understand the words that are written next to it. So getting started with APL, I would suggest there's the APL Orchard. That's a Stack Overflow chat room that you can access. You can ask your questions on Stack Overflow with APL and dialogue tags. You can use the subreddit APLJK. Then there's a book called Learning APL by Stephen Kruger that teaches APL in a very fun way. Then there's YouTube videos by Dialog and Dialog user meetings that talk about the language internals, that talk about how to learn the language, and they teach you the language as well over there. So wrapping up, Dialog APL, what did we get? It is symbolic, concise syntax, array-oriented programming language, object-oriented and functional programming are accessible. It's high performance and works on matrices, works on all kinds of data, and cross-platform. So the theory behind Dialog APL is its notation as a tool for thought, and it expresses programming the way you express it in your head. So the way you think of it, it expresses it in code in the exact same way. There's a quote by Alan Pearless that says, "A language that doesn't affect the way you think about programming is not worth knowing." I would like to end with that. Thank you so much.
Thank you. We have time for some questions.
Yeah, thanks for the talk. So you mentioned Dialog APL is interoperable with Python and .NET. What exactly did you mean by that?
So you can write Dialog APL code in Python as well, embedded with Python, and there's a interoperability with it. And Dialog APL can also access .NET and all of .NET's packages. That's called NuGet. So you can access all of .NET's packages, write .NET code in Dialog APL, or write Dialog APL code in .NET, and it'll run interoperably.
Okay, thank you.
See, beyond the hobby use cases and a few high performance computing use cases, right? Do you see this as a successor to Fortran or substitute for Fortran? Because you can do a lot of these things in Fortran too, but obviously this has its advantages, no questions about it. But where do you see its serious use?
So there's a lot of clients that Dialog APL. So it's a commercially available software as well, and there's a lot of clients that use it in their everyday things. There's use case in the finance industry. There's use case in the healthcare industry. There's use case in the oil industry, as use case in the insurance industry. So there's a lot of people using Dialog APL for practical purposes as well.
So this is an interpreted language, or it's
Yes.
not a compiled one?
There is a compiler as well that's still under development. It is decently stable, but not for commercial purposes.
Oh, okay. If it's interpreted, then it cannot be a HPC compiler, right?
Yeah, but the compiler is there. It'll grow on in some years, so we can see that as well in some time.
I see the main idea behind the whole strength of APL that I understand is that it is very symbolic and whatnot, right? Um, so, like, are those symbols like sort of built into the language? I'm asking this question because, of course, there are functional programming languages like SML, which basically offer you to make functions which use like those similar symbols, and you can have some, uh, yeah, you can have like a similar thing in functional programming languages. So I want to ask, are those inbuilt into the language, or is it like a user defined function, or what?
So all of these are inbuilt into the language, and there's very little specific words that are reserved. So the way we use reserved words in normal programming languages is what you'll use here, symbols for over here. So for example, like I said, you'll use dot slice in a language to slice something. You'd use the down arrow to take something, to drop something out of the array. So all of these are inbuilt into the language, and they're accessible by your keyboard.
All right, got it. Thank you.
Thank you.
See, compiler is all about divide and conquer. Now here you are trying to put things together. Is it not counterintuitive? Is it not more difficult for the interpretation also? It's not high computing performance, and for writing also it is more complex. So is it not totally counterintuitive in a way?
So it is not complex. So like I said, there's a myth that it looks a bit more complicated, but it's really not, and it's very easy to read Dialog APL programs because there's a thing with them that you can read each and every line written in Dialog APL as a sentence from right to left.
See, this has been stated by all the people who have such languages. But you take Scheme or any of those, none of them have become mainstream. And when you
Yeah.
ask them, they said, okay, no, we want the children also to think along these lines. But it's not a possible thing, right?
So that's a matter of perception. Some people like it, some people don't. It's a matter of perception. But this is a different ideology to what normal programming stands for, and it's very close to mathematics. And my argument to that would always be like, if you can write math without using words and without using a lot of things, you can write programming as well with symbols.
Okay.
Thank you.